Welcome to the Minesweeper project on bbteacher.com. Now that we've got our mines hidden, it's time to write the routine that will count the mines and store the number of neighboring mines in each of the cells that don't have mines. To do that, we need to have a good model of what this is going to look like, and what we're going to do is loop through all of the cells of the entire playing area, and for each cell we're going to look at the neighboring cells. Now here the orange colored cell is the focused cell, and it has, as you can see, 8 neighbors either above, below, left, right, or diagonally from it, and if any mines are in any of those, we would increase the count of the mines cell. Here showing 2 mines, we have a 2 stored in the number property of the focused cell. So we're going to do a little loop. We're going to focus on a cell, and then from that cell we're going to go up 1 row and do the next 3 rows down and the 3 columns to the left on the focused cell and to the right, and skipping over the 1 cell that we're focused on, we're going to count up the number of mines in those 8 cells and then store it. So let's write the code. Count the mines. We have to loop through all the cells on the playing area, and so for row as integer equals 0 to board rows minus 1, for call as integer equals 0 to board calls minus 1, and so this will loop through all the cells on the playing area. Next, if the mine field, that's the name of our array that holds the mines, if mine field row and column has mine, then, okay, we don't want to do it if it has a mine, we want to do it if it doesn't. So if it doesn't have a mine, then we're going to count its cells. So there we go. And so it'll skip over the 10% or 20% or 30% of the mine area, the area that has mines. The rest of those, then we're going to have to loop from 1 before to 1 after the mine, and so we'll use R and C for those two. For R as integer equals row minus 1 to row plus 1, and for C as integer equals call minus 1 to call plus 1. And so now we have those 9 cells, 3 by 3 loop here. And what we have to do, though, is to check for edge conditions. We cannot have the R and the C outside of the playing area. So we will check for that. If R is less than, if R is greater than or equal to 0, and R is less than board rows, and C is greater than or equal to 0, and C is less than board columns, and not, okay, when not row equals R and call equals C, that would be the middle cell if those 2 things are true. So it has to have a legal R and a legal C, and it can't be the middle cell. If all that's true, then we check it. Then what we want to do is check it to see if it has a mine. Now, the cell that we're focused on is the cell row call. This is the orange cell is the cell minefield row call, and then we're looking at these one by one, and as we do that, these are the cell RC. So the cell RC are these 8 cells around it, and the middle cell is the cell row call, minefield row call. So we will say this: if minefield RC, that's the one on the outside edge we're looking at, has mine, then minefield row call number plus equals 1. And we hope that does it. Now to check this, we're going to go to the end of the row column loop, and we will say if mine field row call number is greater than 0, then MineField row call view equals number. Okay, let's run it and we can check our work here. And if we're lucky, we'll see the mines and then all the numbered cells showing. We told it to make them all show, and we can check that. Just check a couple of cells where the numbers are large, 3s and 4s and 2s. I see nothing that looks wrong there. Everything there looks correct. Let's rerun it. There's a different board. Looks to me like everything is correct. I believe our counting routine is working, and so that concludes this short section. Thanks for programming along with us, and on the next section we will we'll be working on the next piece of the program where we create the event handler for clicking on the surface. Bye for now.